I think that the song is good. Hello everybody, I hope the hello everybody, I hope that you are doing great in this video. No, it's not a video, it's a live. We're gonna discuss about data structure and algorithm. I have an exam about this topic, so I have to. So guys, I have an exam about this topic, so I have to learn it fastly because I didn't do the work. I have an exam in 6 days, and I have to learn all the data structure and algorithm right now, and do some lead code problem. Some problem we see will be interesting. Just take my cup of coffee. 1 minute, guys. So yeah, I hope that you will enjoy this live. We're gonna do a lot of things together. Welcome to Cytex, my YouTube channel. 1 minute, I will type it over here. Cytex. It's a really good name. Cytex, YouTube channel about computer science. We're gonna discuss all the topic about computer science. We're gonna follow my journey to be the best software engineer in the world, inshallah. I hope the computer science, what the fuck, what am I writing here? Computer science. Oh, let's go. Computer science YouTube channel. I don't know if I have somebody in this live, but I can't check the comments. Sorry. A minute. I think that I'm alone, but I will check the comment. Okay. Computer science YouTube channel. Sorry if I take a little bit time to write something here, because I'm trying to write without checking the keyboard. Computer science YouTube channel. In this video, no, it's not a video. In this live, we will learn some. We will learn some data structure. Because I have an exam about this topic. Structure and algorithm. So yeah, that's it. Computer science YouTube channel. We will learn some computer science stuff, data structure and algorithm. Really like this. So yeah, let's go. So the first one is list. I think everybody knows list. I don't know if I can explain this list. So it's a data structure. I do the teacher right now. Data structure to store data. To store data. Okay. So how to declare a list in C? Sorry, it will be some kind of advanced, but I think everyone here know list. I will do some future in video where I will explain. Sorry. A little bit more. In this video, it's more me that I'm training to develop my skills. So yeah. So a strict list, it's a strict, it's a structure, it's data structure node. We declare a node, we affiliate two type of data. We affiliate an int data where the data is stored, and we affiliate the next node, strict node dot next. Okay, we have another stuff is strict node dot create node. So this is a function to create a new node. We have strict node, new node, strict node malloc, size of strict node. So this one is to allocate the size of the node in the memory and create a new node. So we create a new node. It's this name, by the way, new node, and we affiliate the type of this new node, which is strict node. Don't forget this comma, which is a pointer. I think in my mind I take it like this because I forget it a lot. This one, this comma right here, new node. So we have the new node, we affiliate the two type of data. So we have new node dot data equals value. Value is a variable that we take in as I forget this name, is we take it as oh shit, I I'm that uh as a parameter. As a parameter, just doing one thing. I just will just do one thing, 1 minute. Okay, so I will take this behind me, ChatGPT. I will just do this. Okay, perfect. So we take it as a parameter, that we will give to this function to so they can earn. It's I use it right here, so I give it the parameter 1. It's the value that we will affect to this node dot data dot value. And we have a new node dot next. This one will give the node that will follow our node. So we have new node dot next, not dot next, it's a flash like this. So and another stuff that I will do. 1 minute. Google. Okay. Okay. So it's like an arrow that goes from new node to data, so we can just solve it just the syntax over here about the C. So we have another, and to finish we return new node, the node that you created. Another function that are really important is the function print list. So it's just a function that will print our list. So we have strict node temp dot head. Okay, while temp different from nil, print f %d. So %d will print an integer that is our integer stored in data in the value in the temporary variable temp. It's not a variable, by the way, it's a list, it's a new list. So what we do here is that we declared a new list that we affect in the head. What the fuck, what are we doing over here? 1 minute. Void print list strict node dot head. So we take our structure as a parameter. Okay, we are all right. If there is some person that are really good in computer science in the life, we can practice together. So strict node dot head. Okay, we take our list as a parameter to this function print list. So strict node dot temp, it's a temp 1 minute. I will Google it. We are here to learning together. I'm not expert for the moment about this topic. I have an exam about it, so I have to perfect it. I studied. I have a lot of exams, guys, coming soon, and I didn't study at all. What the fuck? Because I have did a lot of work to do because I'm a mobile developer. I had did a lot of mobile application to do, so I didn't study, and I have a lot of exam coming soon. Ah la la, I don't know what I'm going to do with all this, but yeah, it's what it is. Strict not temp.red. Ah, okay. So this one is not this one. This one, strict node.temp. So we have in our list. I don't know. I can't draw. I don't know if I can. I don't know if I can set up something to draw. 1 minute. 1 minute. I don't know if I can set up something to draw. Uh, 1 minute, guys. I'm just trying to set up something so I can draw. What the fuck is that? What the fuck is what the fuck is that? What the fuck? I'm just no, not this type of something to draw. What the 1 minute, guys. I'm just trying to think something. Oh, that's perfect. That's perfect. So yeah. Ah no. How to how to remove what I done? Ah. So I'm just adding this to our OBS. 1 minute, guys. Windows capture. Okay, that's perfect. So yeah, I just have to retrieve this. So data structure. I'm not good data structure. I'm gonna do the role of the teacher in C. So yeah, guys, I will explain this to you so you can master it more easily. List. Okay. I can't do a lot of another. No. Okay. Ah, let's remove it to all the. I don't know how to use this. Sorry, guys. Oh. Okay. Okay. So yeah, we have data structure in C. Okay, we have a list. So a list, it's a type of data that have two. Okay, it's something like this. I will explain it right now. Okay, and we have a pointer here in the head think it's something like this. Head. Ah. I'm, I'm too bad. Okay, that's the head. Okay, head. So yeah, this is a list. 1 minute. How can I? Oh, voilà. Up. This is a list. Okay, this is. I'm discovering these tools too. So this is a list. It's a type of data where we have two things. Here we have our data. Our data. Let's suppose that it's an integer like 4. 4 is my favorite number, and this is a pointer to the next node, so it refers the the type of the address of the future node. So we have like this node has an address, this number as an address, so here it will be this address, so the arrow will go over here. I don't know if I'm a good teacher, but yeah, I think you understand because you are so smart, not like me. So yeah, this is, and it continue like this. So we have this one, it will have another type of data like 14, and the number of the address of the next node, this one, like let's suppose that he have an address 14, so yes, so it has the same address. That's a list, by the way, and it's type of data. It's a data structure that store data, so we can store data using a list like here. So this one is a head. A head is the pointer that will have our list. It's the first one in the list. So what are we doing over here with our code? Over here we are passing the temp to the head, so we are giving the head. I will explain it like this. Where is my VS Code? Wow. Okay, so here temp is over here, guys. It's take the place of a head. Temp is here. Temp take the place of head, so temp and head are in the same place actually. That's it. So temp take the place of the head, and we are doing a while loop over here where temp doesn't equals to null, and we print the value of temp, the value that are stored in the node. I will explain that. I will explain that 1 minute. So right here, we are printing the value that are stored in this temp. In this case it will be 4 printed, so in this case over here we will print what the fuck is that? This is all, but it's not print, okay? So in this case we'll print 4. It's the thing that we will print in this case. But now while temp is passing a minute, this one, okay, while temp is passing in our data, while it's a while loop, so it's a loop, it's pursuing this data. So okay, gonna first temp. Okay, this one. Okay, so temp will be right here now. This is temp, and in this case we will print 14, and we continue in this case till we are in null. This is null. It seems that our data structure end up, so we don't have any element after that till we have also temp will pursue all our data structure till he is finally arrived in null. So yeah, I'm just gonna clean this. It's what temp is doing. So yeah, that's it. So yeah, let's finish with the code now. Printf, we print our data, temp.next, printf, and we print f null. If the loop is finished, then we can print f null. So yeah, that's it. And now we are in the int main strict node.head. So in this case, we just use our function to create different nodes. So we're gonna declare a new node, affiliate this in the head, and create new node 1. So after that we have head.next, we create node 2, and after that we will have head.next.next. This gonna create our third node, and after that we're gonna print f head. So yeah, that's it. If I run this, so yeah, that's it. Our code is functional. So this is was about the list. I'm just gonna check it another. So this is what a list in data structure in C. So we declare our strict node int data strict node data.next, the next data. So we give it two things in our strict node, and don't forget this one, by the way. After that we have a function that gives us a strict. It's a data structure. We have a node. It's a type of strict that are node. We're gonna return a node. This name is create node. We give it a parameter that are value and integer. So we have strict node.new node. We give it, so it's a new node. It's a new node. It's a new structure that are node. And we have strict node malloc size of strict node, and this one. Okay, we are good over here. Strict node malloc, don't forget this stuff. I forget it a lot, me. Strict node malloc size of strict node, new node.data take value, new node.next take next, and return a new node. So yeah. Void print list strict node.head strict node temp.head. Okay, while temp different from null, print f %d temp.data temp equal temp.next. Easy, it's to print our list. If the while loop end up, that means that we are in the null and the list end up. And we have int main, where we're gonna check if our function are doing their work. So yeah, this was about the list. Now we have the double linked list, so I'm gonna explain it over here, and we're gonna throw don't forget to follow Cytex, everybody. I'm taking off my time to explain to you, so we can grow together. Together we're gonna be the best. But I have an exam, so I have to work. Oh la la. I'm not perfect, guys, for the moment. So I will do a lot of mistakes, and it's not bad if something are more experienced than me, we can. So I'm a beginner right now, but I will be professional one day. Strict node. So we have strict node. Over here it's different from the list because this one it's not a list. It's double linked list. Uh, double. I think this. I don't think we write it like. I'm just gonna check how to write it. Oh, okay. I write it like this. I'm really stupid now. So, yeah, it's a double double linked list. Double linked list. Okay. This one is another type of data structure. It's double linked list, and we also will have this in the exam. So I don't know how can I do. I have an exam in 6 days, guys. I'm really bad. Strict node int data. Okay, so in strict node, now I'm gonna explain this. Another one. I'm the teacher. I'm our teacher, guys. Yes. So we're gonna take a new paper. Oh, I start to learning this stuff. Uh, I'm becoming a teacher. I should teach myself. By the way, double linked list. Double. It's right. So I explain it to you so I can understand it better. Double linked list. I should teach myself. Okay, so it's data of data. We have the head. It's the same. The fuck. So yeah, we have the head. We have. It's like this. It's like a list. For the moment, let's suppose it's a list. So we have two type of data. Okay. For the moment, let's suppose that it's a list. Okay. I did it really long this time. I don't know what I'm doing. Okay, let's suppose it's null. Over here, it's the end of the list, so null. Okay. Double linked list. And this what I did right now. It's a list, okay? So we're gonna give it some data. We start over here with the for my favorite number, 14, 7, 9. What is my favorite number after 9? 2, and the end one. The note that I will have in the exam. 18. Inshallah. I don't know. 18. Okay, 18 it's good. Okay, and it's the final note. So, inshallah, just I don't get this. Okay. Bon. So over here it's double linked list. It's not a list. So we just gonna this one this this one is gonna give you the node after this one, but now it's double linked list, so we have something like this. I don't know if it's really like that, but I will do it like that so you can understand. Okay, we have over here we have another one. This one is this one. It's the a node that gives us the precedent, the predecessor. So we store the address like this. We have so 2. Over here we will have son 2. So it's got her precedent is son 2, and here's the next. His next is 4. So over here we have this one is named 4. So over here we have the next node that are coming after this one. Let's suppose it's 3. The next node that are coming after 3 is 4, and the predecessor of the node 3 is the node this one. So yeah, this is a double linked list over here, and we have also the head, and I think we can access to the last element that are I'm gonna check what is name. So I'm gonna Google it. The last element of a double linked list. If you don't know something, Google it, guys. Double linked list. Oh, it's exactly how the same that I did it for you guys. So yeah, what is his name? So we have the head, and we have. So I didn't read it. I didn't find it over here. So it's more likely something like this. I'm gonna show you. I think that I found something interesting, so I'm gonna show you. So I'm gonna show you 1 minute. So yeah, guys, it's something like this. So we have our head, the null over here, the precedent, and the next is over here. The precedent of this element is the null, so that thing confirms that he is the head. After that, we have this element that have the predecessor and the next element, and we have our last element that are the next of this element is null. Doubly linked list in data structure. So yeah, each node is connected to its previous and next node using previous and next pointer. Okay, so that's it. But so we have the head and the tail. I think it's the last element is named tail. No, what the fuck what I'm talking about. It's the Q normalement. Like in French, it's la queue, but in English, I don't know how to I'm gonna Google it. Google translates. So la queue. The tail. Okay. So it's the tail. The tail. Perfect. Is the tail. The last element is named the tail, and we have a pointer to the last element. That's perfect, guys. Okay, so that's it about double linked list, and we're gonna check the code right now. So I'm just gonna remove this, and we're gonna check the code. So it's a strict node like the other, and we have two type of data. We have three type of data. Sorry, we have int data and strict node dot swift, which is the node that will point in the next node, and we have strict node dot press, which will point in the predecessor. Okay. So like the other, we're gonna create a new node. So we're gonna add a function that will create a new node. This function will be named strict node create node. We're gonna give it a parameter value, int value. So we have strict node dot new node. So new node, it's a new node that will create, and it's a type of data that have strict node. So here we will give it a space in the memory with the function malloc size of strict node in function of the size of this node. Don't forget this. I forget it all the time. I know I'm talking to myself because I'm revising so for the exam. Please don't forget this, Shaky. Please don't forget this. I forget it all the time. So we have strict node new node, strict node, this stuff, no, don't know what his name, and malloc to store the size of certain node. Okay, so we have new node dot data will store the value in this new node. Okay, after that we have new node dot press which will have the value null. What the fuck is this? Ah, okay, create. What the fuck? Why he has the value null? I'm just gonna check something. The fuck? To be sure. Ah, okay, so we create our first node. Okay, so they have the value null, and new node dot save have the value null, and we return our new node that we created just now. So yeah, after that we have a function named insert, and this function will insert an element in the. So right now I'm gonna start to my revision for the exam. We have, okay, so I have a function insert and computer science YouTube channel. It's a live Citex. Don't forget to follow Citex, guys, to follow my journey as a computer science student and mobile app developer, full stack developer really soon. Node dot new node, create new node. Okay, so over here what are we doing, guys, is we create a new node and we give it the value int that we take in as a parameter over here. And I don't know if you check it, but over here we have two things. These two things refer to that we have two type of data, the sweep of the precedent, two stuff like this stuff. So okay, we have two. Okay, so strict node dot head int value, strict node AC, we create a new node. Okay, after that we're gonna check if the head is null, then create a new node, return. So first of all we will check if the head is null. If the head is null, we're gonna insert it directly and give us the return easily. So we will check if the head is null. Okay, if head equals null, we'll have pointer to the head is null. If the pointer in that point in the head is null, so we will have head I think head, we're gonna give it a new node. So is the function head, we give it the new node that we just created with the function create node, and we return easily. After doing that we return because it's the first element. That's it. So if this condition are not realized, so the head isn't null, the pointer that point or the pointer that the hand point on isn't null, so we're gonna have to do a lot another stuff. The stuff that it's gonna give the value of the head in, we're gonna have a new pointer which is temp. This pointer will point into the head like what we did before. So this pointer will point to the head. Okay, so this pointer will point to the head. Okay, strict nodes dot temp, this pointer will point to the head. Okay, that's good for the moment, it's good. So over here I will did it again, sorry, we'll memorize it. So we have strict node. We're gonna create a new node, name it temp. It's a pointer type, temp. This pointer points to the head. That we take as a value. Okay, so that's it. Strict node dot head, this value point. Okay, so what we'll do, it's a really easy one. So you do a while loop, while temp so while temp dot next next, why she didn't, no, dot sweep in this case, different from null. No, so different from null. While this condition is realized, we're gonna do temp will receive okay, temp dot next dot sweep. So this will check all our double linked list. After we finish this, we are in the last element, which is null. So the last element temp, we are actually in the last element. So temp dot no, not dot, I don't know why I named this not dot, but temp dot sweep are going to receive our new node that we just created, and temp dot I don't know why I named this not now. Okay, and our temp, okay, so new node, our new node in his case will receive the value of temp dot precedent. No, likely it seems like this, temp dot precedent. Okay, so I think it's something like this. So we have strict node dot temp equals to head, okay, while temp dot net dot sweep for sure, different from null. Okay, we have temp equals temp dot sweep, okay, temp dot sweep equals to new node, and the new node dot press. Oh, sorry, it's a big mistake over here. It's not temp dot press, it's new node dot press. So the predecessor of new node is temp, and the temp of the next element after temp, the sweep event of temp, is new node. So yeah, that's a function that will answer our node in the new node in the last element. I'm just gonna check why we did this. Gonna check this out. I'm I'm just gonna Google it. Okay, so you have me over here how to. Okay, 1 minute, guys, I'm coming. I'm just googling this stuff. Okay, so now just why we used that. Why okay. So guys, we use this if you want to change our head. So the change we can change our head with this function. But if you want to traverse our list only, we can just use this. That's the difference if you have a question. So yeah, that's it. Void answer and after that. So I'm just gonna resume what we did for the moment. We have declared a new type of structure which is node. We give it three stuff that are the data, the next node, and the predecessor. Okay. We have strict node that create node int value, strict node dot new node, strict node dot malloc is will give us the size of the data in our data. New node dot next is gonna give you the value. New node dot precedent. Okay, return new node. Void answer and void answer and. So we have strict node dot head int value, strict node dot new node create node value. If head equals null, head new node return. So we're just gonna return. We're just gonna give it the head the value of our new node and just to do a return. Otherwise, we have strict node temp. We're gonna point into the head with a new node named temp, and we're gonna traverse all our list to access access to the last element, sorry, to access to the last element, and after this we're gonna give the new node to the last element after the last element, which are pointed by temp, and we're gonna give the precedent of new node, which is temp. So yeah, that's it for the moment. Now we can move on to the next. So after inserting the element in the end, we have the function print list, which will print our list. Okay, so we have void print list print. After that we will did some lead code problem. Yeah, this live is going to be really long, guys. Oh. So we have print list is a function that we will use right now. So print list, we will give it the strict, so we don't need to access to the first element, which is head. So we're just gonna give node like this, node dot head like this to access to our structure in the head. So we're gonna traverse it or do whatever we did with. So it's a function that will print our structure, our data structure. So it's the same, we can say that it's the same as what we did before. So we're gonna declare a new node, that is temp. Will give it the value of head. We'll have a new pointers in the head over here. It's new pointers that point temp that point in the head. So while temp that swift is different from null, okay, over here temp dot swift is different from null, we're gonna just do temp okay, we're just gonna do temp. Okay, 1 minute, guys. It's gonna do temp dot temp is going to receive no temp equals to temp dot swift. Okay, this is the right answer. Okay, strict node dot temp. So here we traverse all our data structures. So we are in the list element, we are actually in the list element. So we just gonna do temp no, I'm doing what the fuck I'm doing. Okay, so we are printing our list. So before we do this, I think that we are doing a function that, okay, so over here we're gonna print, right guys, gonna print our function that we are working. So it's gonna be %t because we print an integer. So it's the string, the type of data that we'll print is an integer, so we'll print an integer %t, and we have a string value. Why they didn't give it to me? Okay, I think that I have to do it like this. Temp.data, I think. Data, exactly. So we will print f, okay. Otherwise we'll print that we are in the null element. Null. I think it's something like this. So this is a function that will print our list. Oh, so it's a void that will return. So we have strict node temp.head. I give it the first element. While temp, no, it's not temp.view, it's temp only, because we're gonna traverse all the list. While temp different from null, print f%temp.data, temp.shape. Otherwise we're gonna print f null, and we give it the line, okay, the space. So yeah, so this is how we print the list forward. Print list, print double list, but yeah, okay, print list forward. Now let's check how we can print our list. Print list backward. Okay, so this is a different type. So yes, so void, it's a different function. So we have print list backward, print list reverse, it's reverse, gonna give it strict, so we're gonna give it the tail. Yeah, it's the tail, strict node. Tail okay, after this we're gonna give it a tail. So we're gonna create a temporal variable, which is temp strict node dot temp temporal variables, that's gonna point to the tail, exactly. And after creating a temp, we will just do a while loop like what we did before. While loop, what the fuck I'm doing? While temp is different from null, we're just gonna move on to the next. While temp is different from null, So first of all we'll print the value of the temp that we are in. Okay, so we're gonna do %d, print the value of our temp. So it's temp dot data I think. Okay, so yeah, and after that we will go to the, so after that we'll do temp receive temp, the precedent element of the temp. So temp dot press. Okay. Yeah, that's it. After that if we finish, we're just gonna print null. Okay, no, not her. Into the number point. Okay, so this how to print list backward. Just check if I'm right. So void print list reverse strict node dot tail. We can access to the tail, which is the last element of the list. Strict node dot temp tail. While temp different from null, we're just gonna print f our temp data and temp dot precedent. So we're just gonna do the precedent temp. So 1 minute. Okay, so we have, okay, that's it. Let's get it. Print f null. Okay, so yeah, that's the function that we use in this case in double linked list. So we're just gonna do the main right now. I don't have a main. Okay, perfect. So we're gonna give to the head the value 0, so the value null, so we are sure that our list is our list don't have any element on it. So we have the head equals to null. Perfect. Okay, so we have insert and we have our pointer to the head. Okay, and we have the value 10. Insert and we have insert and value of the head, and this value which one, 20, and we have insert and sorry our other element. We let's suppose it will be pointer in the head and with this value 13. So we're gonna just print f right now our list. So just forward reversal. Forward traversal. traversal, and after that we're gonna print our list. Print list, so it's the function, and we're gonna give it the value of the head. So after that we will try this code and check if it's right and we didn't did any mistakes. I'm just gonna check if I didn't miss any of this point. It's not seems that I missed something, so yeah. In function array, '27. Okay. No, we just return, we don't need to give it a value. Okay, that's ran perfectly. So we have 10, 20, 13, and we traverse our list, printf the list. So it's worked perfectly. Our code is really good designed. So we insert element in the end and we create f. Okay. So this is about the double linked list. So yeah, right now guys, after we finish discussing, let's do a resume. We have double linked list, so yeah, strict node, we gonna declare this double linked list. It's strict node int data, we give it the value that is an integer, and we give it the next element and the precedent element. Don't forget these 2 pointers please. So this is the declaration of our double linked list. The first function we're gonna discuss is the function create node. So this function will create a node in the list. So it will give us a strict node, create node. So strict node dot new node, we give it this new node, and we are now give it a value size in the memory with the malloc, and we're gonna give it a different type of value, and we're gonna return our new node that we just created. After that we have the function void insert, and this function will insert an element in the end of our data structure. So it will insert in the end of our doubly linked list. So we have strict node, new node, create node. So we will create a new node with the parameter value that are given. So why we use two of this? Because we want to access to the head and change it. We want to access to the head to check if it's null, and if it's null we're gonna give it a new value. So we're gonna check the head. So we use this if you want to check the head, and we use this if you want to just access to the head but don't change it. So yeah, in this time, look at this, we didn't change the head, we just give a pointer temp that point to the head, but it doesn't change the head, it's just traverse our list. Okay, so yeah, we will insert an element in the end. So we have strict node, new node, create node value. if head if head equals to null, we will give it, I always forget this. Okay, pointer that point to the head is equals to null, it's a condition, so this is why we use two time, and this is an assignment, it's different. To use a condition we use two, to do an assignment we use only one. It's a C, it's a syntax of the C. And after doing that we just return, otherwise we will go to the strict and affect the do give a new pointer that point to the head, and we're gonna traverse while temp dot suivant different from null. We're gonna do temp dot suivant that will traverse all our list and access directly in the last element. We do temp dot suivant, give it new node, and new node dot precedent, give it our temp. So that's it. After that we're gonna print our list forward. So it's really easy, we're just gonna do print list strict node head. So we have one minute guys, I'm coming. I will just do one thing. I'm coming. Oh yeah, hello guys. I am here right now to finish this. Hello, hello. Did you listen to me? So I will just check the song if everything is okay. So everything seems good. We can start. So yeah, it was all this about the list. Now let's discuss about stocks. It's the next topic. 1 minute. I just to fix. I just have to fix one thing. So yeah, let's discuss about stocks or over here. So I'm just gonna go to the dashboard to explain you what stocks are. Okay, so yeah, I'm gonna start the stream. 1 minute, guys. So yeah, this is stocks. Just move on this one over here. Okay, so I know. So yeah, this is stocks. So let's start. We're gonna console. We're gonna have a new page. Okay, so we're gonna talk about stocks right now. I'm just gonna 1 minute. Gonna just do one thing. So yeah, stocks is another data structure. So we have over here stock. So it's another type of data structure. It's a data structure of the type LIFO. It's a LIFO data structure. LIFO. What does it mean, LIFO? It means last in, first out. So last in, first out. I'm gonna explain it right now. So we have a stack is something like this. This is a stack. So we have a data, a piece of data coming out like this, and we have a piece of data, a lot of data like this. It's data, so we have 4, 14, 0, and whatever. So a stack is a data structure of type LIFO. What does it mean, LIFO? Last in, first out. So the last element, let's suppose it's 7. It's gonna enter into the stack. So we have the same element over here, which is 7. He was the last element to enter to the stack, and he is also the first element who is going outside of the stack. So with stack we have two operations. The first operation is when the element enter to the stack, so it's the push element operation. And the second operation is the operation when the element is going outside of the stack. This named a pop operation. So yeah, that's it. That's what is a stack. So if you want something, so if you want to clean all our stack, let's suppose we want to clean all our stack. We just have to pop all the element. So the first element that will be pop is 7. So we pop 7 here. After we pop it, 7 is going to go like this. After that, we're gonna pop the second element, which is 0. Gonna pop here 0. After that, we're gonna remove it. So if you want to clean up our stack, we have to pop all the element. Pop the third element, which is 14. And finally pop the last element, which is 4. So it's always like this. If you want to clean up your stack. Now let's suppose we want to add new element in the stack. So what we have to do is you have to push this element into the stack. We have to do push. So how we push this? We push the first element 0. After that we will push the second element, which is 7. So yes, let's clean up the 7 because we push it. After that we have to push the third element, which is 14. Finally we have to push the last element, which is 4. And that's how a stack works. It manage data in this clean way. And I don't know if you see, but we just reverse our stack over here. So yeah, that's it. That's a stack. I will do a resume for you. So stack is a type of data, is a data structure that seems like this. We have different type of data, and the most important thing is that it's a LIFO data structure. So the first element to enter is the last element that goes out. This is a stack. So yeah, let's check out the code right now. In C over here, as always, I'm just gonna check the code. So over here I have to add a new file. Let's declare throw.c. Now let's do our include. So we are going to include studio. This is something that you have to do always in C. Don't worry about it. Always in C, sorry. And we're gonna include the stdlib also. So yeah, now how to define a stack? It's the same thing as we defined a list before that. Define stack. So it's exactly the same thing. We just do struct, because what? Because all the element in the stack have the same thing that our list had before. so it doesn't change anything. So we have int data. It's just like we declare a list, and we have strict, no, not this one, strict node dot next. Let's just do sweep, because I like to do it like this. Don't forget this one, because I always forget it. So that's it, how to define a stack. Now we have two functions in stack. We have the push function, and this is the most important thing in stack. So the two function we have, before that we have the push function that we use to add element in the stack. So it's the push function. So yeah, it return an integer. So we have pop. So it's a function named pop. We give it the struct that we just created. Control Z. The struct that we just created, which is node, and we're gonna access to the top. So we just do this. We're gonna access to the top of our stack. So let's just do this, and if we have to do a verification now. So if the top pointer that points in the top equals to null, du coup we just have to do printf that our stack is underflow. Stack underflow. Don't forget this, and we return -1. So otherwise we have to declare temp variable that points to the top node. What the fuck, node temp. So it's a variable that point to the top, so we have to int pop it. So it's a boolean. No, it's not a boolean, it's an integer. Sorry, I don't know why I said that. Temp refer our data, and now so just pop it is a variable that's stuck temp.data. Don't complain about it. Top equals to top to the next. With width. And now we can just free our temp. And we return the value, which is pop it. So yeah, this is the push function. We check if the top is over here, and we do the return of the value that are in the top. We push it to the top. So let's now talk about oh sorry, what I did over here was the pop function. No? Sorry. Now let's talk about the push function. Oh sorry guys. Function. Push function. A function when you push an element to the function. I said that. Okay. So when you push an element to the function, we return a void. So this was okay. We push an element into the function. So we have to give it struct node 2 because we have to access to the top, and we have to give it int value, which is the value of the element that we will pushed in. So we have to create a new node. So struct node, it's the same thing that we did always do. New node. So it's struct node malloc size of new node. So normally is this size of struct node, sorry, size of struct node. Control Z, struct node. This is the how we create a new node. Now we have new node. We're gonna give it the value that he will have. New node dot, no, it's not dot, man. Dot data equals to value, and we have new node dot swivel, which will give you the top. After that we will have the top, which is new node, and that's how we pushed our node into the top. So I think everything is clear over here. Now we can just do how to print the stack, which is really easy. It's the same as what we did always. Print the stack. So it's return a void, print stack, I'm just gonna do this one as variable. Okay, so it's strict. See, I don't know, I click 2 times on strict. So over here we don't need to access to the top, so we just do it 1 time. The fuck is I just clicked on enter, so it gives me this top. After that we just do our while loop. While top different from null, we just gonna print f %d sorry, I forget this one. %d, and we're gonna do an arrow so we can check it more easily when we run the code, sorry. And we're gonna give it top dot data. That's it. After printing it, we're just going to the next element. Top equals to top dot next dot sweep. After that, if we finish, we just print f null. That seems that we finish to print all the stack, and we're gonna leave a line. So this is how to print a stack, and now we just have to do our main. So we have struct node dot stack equals to null. So over here we just initialize a stack at null, and we're gonna push some element like what we did in the presentation. So we're gonna push stack that have number 10. We're gonna just do this, and we're gonna push another stack that have the number 20, and we're gonna push a final stack that have the number 13. Stack have number 13. And over here we can print f our stack, print stack, sorry, not know what I did, print stack, our stack, and we finally can just print f. Let's say puppet Puppet. I don't know which element is Puppet, so let's give it %d and go to the new line. Don't forget this new line on like this, and we just pop our stack. Scanf. What the fuck is he doing? Stack. So yeah, that's it, and we print f the stack. And finally we return 0. So yeah, I just see if I miss something. Doesn't seem to, so let's go. So yeah, look, the code run perfectly. Just have some few error over here. I think argument 1 of printf are incompatible. Oh, sorry. Print stack. Not print. The fuck. Okay, and the code ran perfectly. So yeah, everybody, this is stack. Okay, so yeah, let's explain all the code. So over here we have defined a stack is the same as what we defined before. So now we have the pop function. We initialize an element int pop strict node. We give it the top because we're gonna modify it. If top equals to null, stack under flow return -1. Printf return -1. Stack over under flow, so we're gonna return -1. Otherwise, if the strict node dot temp, otherwise we're gonna initialize an element temp. We're gonna initialize a pointer that point to the temp int pop that will store temp dot data, and top is going to be top dot free temp. Free temp. Okay, I don't understand this. I don't understand this, so I have to copy all this. So yeah, guys, 1 minute, please. everybody, I'm coming back. Now we discuss about the stack data structure. So what we said is it's a data structure that we're gonna use list to define it. So we declare struct node int data struct node data dot swift. After that we declare the two functions that declare our stack, which is pop function and push function. So first of all, for the pop function, it's a function that's gonna pop element from our stack. So we have to give it struct node dot pop. Why we use it two times? Because we have to access to the first element in the top. So if the top equals to null, it's a verification over here. We're gonna print f stack underflow and return -1 that the pop function doesn't execute. Otherwise, we're gonna have to declare a temporal variables that is a pointer that point to the top. We init popped that will have the data stored in the top, in the temp. That so we're gonna access in the data stored in the element that are in the top of our stack. After that we're gonna give to the top, the pointer of the top, the pointer, the next pointer. So we're gonna access to the element that are below, and we're gonna free our temp and return the popped. That's it for the pop function. We have the push function, which gonna push an element to our stack. So the first thing that you have to do is to create a new node. So we use this to create a new node. We create a new struct, name it new node, and struct node we give it the malloc, which is a space in the memory size of struct node. It's really similar in anything, so we give it the two first. We have new node dot data, give it value. After that we have new node dot swift, give it top. After that we assign the top to the new node. So the new node dot swift are gonna receive the top, and after that we're gonna assign the top to the new node. I will explain this in our so I don't know really how can I explain this. I'm gonna do something like this. 1 minute, guys. I think I'm going to do something like this to explain it really good. Okay. Let's do this. Oh, that seems really cool. Okay, so what we are doing right now, is you are our new node. We give it here next element after our new node that we just created is the top of the stack. So just look at this. We have our new node. Just to remove this, we will add this element into the top of our stack. So we have the new element that we created. Her swift is this element, so we give it this swift. This is her next element, the swift. like what we said there. After that, the pointer that point in the top was here. This is the top. The sweep of this element is the top. After we give it the sweep, the top is gonna be assigned to this element. So this element, like we did here, the type received this new node. So the top will be this element right now. And in this case, what we just did over here is we finally add this element into our stack successfully. So that's it for the push function. I think that it was clear. So after that, we're gonna use the function to print our stack. So we have to do just a while loop. While the top isn't null, we just print the element and we go to the next element. After that, we print, and now we just have the main where we're gonna do different tests to see if the code run perfectly. That's it. So guys, if you really liked this video, don't forget to subscribe and drop a like. Scitex for more tech stuff.
Le monde fait comme les autres, oublie tes rêves. Je suis plus jeune que toi mais je te dépasse d'un millénaire. Oh maman je vais vivre l'enfer pour donner le paradis terrestre. Je suis dans un bon mode, viens pas me parasiter, ouais. J'ai dépensé
hello everyone, welcome back. So we discussed about the stack data structure. We talk about how to define a stack, how to pop, how to push, and how to print the stack, and we did an example. And I told you that you should subscribe to my channel and drop a like. So now after finishing this, I just wanna confirm one thing about this stuff. Just 1 minute, I'm gonna take this to documentate about it. So just 1 minute. Okay, so I'm gonna explain it fastly. So here, where is my drawing dashboard? Okay, just over here. So yeah, just gonna make it more clear. Okay, so yeah, here we have our stack, which is represented like this. I'm just gonna remove this and remove this. So we have our stack over here. I think everybody know what's stack right now. It's represented like this. It's a list of element. So when we add a new element, the pointer initially point over here, pointer of the head, the temp pointer. This pointer we're gonna give it to the next element using this one, using this instruction. So the actual pointer temp equals to temp dot sweep. Using this, our temp is gonna move here. Temp. After that, we can just free this one. So we use the predefined function free in this one, so it will remove it. It will pop it outside of our stack. And finally, the new top is this one, is the new element on the top. So that's actually what is happening here. So yeah, that's it. So we finished to talk about stacks. Now we can move to the next data structure that we will talk about, and which is Q data structure. So Q is a data structure in the form FIFO. It's a FIFO data structure. What do you mean by FIFO? We mean that first in, first out. So the first element is gonna enter here, and it will be the first element who goes out. So it's something like this. So this element 4 will enter over here. After that, another element will come. Let's suppose 5, and he will come here. 5. After that, we will have, I'm gonna do a little bit. After that, we will have 6. 6 is gonna come here. After that, we will have 8. 8 is gonna come here. So the first element that enter, which is 4, is the first element who will go out. So 4 goes out, and we just pursue like this. So we have 5 that will goes out, and we pursue like this. After that we will have 6. After that you will have 8. So this is Q. So this is Q. Explain it easily. Hope that everyone understand. Now we can just move on to the code. So yeah, so this is the code for the stack. Now we're gonna add the new file 4.c, and we're gonna discuss about Q. So we're gonna include to start After that we're gonna include and first of all we have to define our queue and a queue node. So it's a strict, it's the same that we defined list and other stuff. So it's strict node. We're gonna give it int data and we're gonna give it strict node dot next. So yeah, this is how we define a queue. So after that we have to define a queue node. So we define a queue node structure, sorry. So the queue structure will be strict queue and it's gonna be strict node font. So it's the first one, font, and horaire. This is strict queue. Now we have to create a new queue. So we have to define a strict that will return a queue and create a queue. Its name is create queue. So it's not gonna take parameters. So yeah, let's start. First of all, we have strict queue. We're gonna define our queue. The first element, it's likely what we did a lot of time. So we have a strict queue. So we have strict queue. It's the same as what we did a lot of time. Malloc size of struct que. So yeah, so we're gonna initialize the que dot front and que dot front. It's likely what we did before, but now in que it's not changing a lot at all. Que dot ref equals to null. So yeah, everything is the same if you check good, and we're gonna return our que. Return que. So yeah, after that, after creating the que, we're gonna do the onCue function. onCue function. So the first thing that we can do in our que, I'm gonna explain this because I don't explain it. So we have our que over here. We have two actions that we can do in our que. The first action will be onCue. This is just entering an element to the que. And the second action that we can do is just deque. So it's just removing an element from the que. That's it, it's the same element. Four, always the number 4. So that's it. I'm gonna write it first in, first out. Yeah. So that's a que, everybody. So now we can return to the code. So we're gonna write the onCue function that will enter the first element in the que. So it's gonna return a void. We have onCue struct que and we're gonna int value. So it's take as a value the que and an integer value. So yeah, so first of all we're gonna create a new node, struct node, equals to strict node malloc size of strict node. So yeah, that's it. After that we just gonna give the value for our new node. So we have new node dot data equals to value new node that next equals to null so that's it. So we have an if statement. If dot rear equals to null, then we will dot prompt equals to, that means that there is no element, so we're just gonna go for it and add it in the list. The fuck, Control G, equals to the node that we just created, new node, and we're gonna return. So yeah, that's the function on. After that, if it's not null, so we just do dot rear dot next equals to new node. Or dot rear equals to new node. So yeah, that's it. That's the function on function. After that, we will have to write the dequeue function. So I'm gonna declare an integer dequeue type strict q dot q. So it's an integer dq, and if q dot font sorry, equals to null, then we will have to print f q underflow. Otherwise we have to return, in order to that we have to return -1. So let's say that we return -1 to say that the operation doesn't affect you. So after that, if it's not equals to null, so we have to create a temporary pointer. So I think everybody knows that point to the q, that point to q dot front. And we have enter removed, temp dot data. What the fuck, data, yep, temp dot data. So we have count q dot front equals to q dot front dot next. So if q dot font equals to null, we have to q dot rear equals to null. So yeah, after that we just have to free our temp. More easily than that. And after that we return removed, and we finished with the q function. So yeah, after that we have to void, we have to print the queue, so I'm gonna leave it as a comment. Print the queue, so it's a void print queue. Sorry, just this one I'm gonna like this. Okay, so we're gonna give it strict queue dot queue, or like this. So we have strict node temp equals to queue dot front while, so we initialize a temporary variable in the front. Now we're gonna check if the temp variable that you initialize is different from null. It's just like what we did before. The function print is the same for everyone, and this we're gonna print our element, print f %d because it's an integer, and we're gonna add the finish so it will be clear. Sorry. And we're gonna print temp.data data. So yeah, temp equals to temp dot next, and it's all about it. Now if it doesn't work, we just gonna print f null. Yes, so this is how we print the queue. Now I think we can just move to the main. So main is when we'll use different stuff to try understand it. So we have struct q dot q create q now and q dot one to try if everything is okay, and q two, and finally you're gonna q dot two. Now we're gonna print q. That's it. Now we print f. they could %d slash and print the q of q. So print q dot q. Finally we return 0. Just gonna check if I don't forget something. No, everything seems to be okay. Yeah, I think we just can run it and see. The fuck? 1 minute. Okay. Yeah. What the fuck? I don't know what is happening. Let's try it again. Okay, I just misclick over him. sorry. Sorry. Normally it should run. Okay. Perfectly. So that's it, guys. That's a queue. That's our structure. Don't forget to follow Cytex computer science world. So yeah, thank you everybody.